Wasabi, you guys. This time I'm going to show you 10 integrals that you must memorize by heart. The first integral is, you've probably seen this in a lot of videos, but it looks like this. Okay, whenever you see something like this, don't waste your time doing multiple substitutions. Like this, the answer is literally the highest titration. I don't know what to call this, but it's the highest one. That's it. That's all it is. That's your answer. You're done. So whenever you see an integral like that, it's just the highest peak. Next integral. The second integral to memorize by heart is x e to the x. Okay. Whenever you do a lot of substitutions, like let u equal something, and then you end up at this stage here, you might as well memorize this, because this comes up a lot. So the integral of this is x e to the x minus e to the x plus c. And that's it, right? It's just integration by parts, e to the x, e to the x, e to the x, right? And this is just, you can easily see that this is e to the x, x minus 1, right? So that's all it is. In fact, what you can do is whenever you see something like this, e to the x, all this is just e to the x times, and then it's x4 minus the derivative of 4x cubed plus the derivative of this is 12x squared minus the derivative of this is 24x, the derivative of this. So the signs alternate, and you just keep on deriving. You keep on deriving one to another. And plus c, and you're good to go. Right. So, but in general, this integral here, it's just xe minus e to the x, or you can write it as x minus 1 to help you easily memorize it, plus c. All right. The third integral that you must memorize by heart is ln of x. Okay. Yes, you could do integration by parts, like, you know, right, and then you just do whichever. But it's just, at this point, because this is so commonly shown, like, you might as well just memorize this. This is just x ln of x minus x plus c. Okay, so that's this integral here. Okay, that's all it is. You can do integration by parts, but it's just a few steps, but it would just be faster to just memorize it, and then guaranteed you definitely beat the opponent for sure. The next integral to memorize by heart is tangent square. This you must memorize by heart. The integral of tangent square is tangent x minus x plus c. The reason being is because tangent square is secant square minus 1. And the integral of secant square is tangent x, which should be memorized because we know that the derivative of tangent x is secant square. So, because of that, the integral of tangent square is tan x minus x plus c. It's good to have that memorized because sometimes in very competitive integration B, you'll come across like this. And you're probably thinking, what the heck is this? Right, what is this? How do you integrate this? Well, let u equal tangent x, because you you memorize that tangent square, the integral of tangent square is tangent x minus x. So deriving it gives you tangent square, and then this is just ln of u, plug in u, then you're good. So it's good to have that memorized. The next integral is dx over 1 minus x squared, right? Some of you most of you would do partial fractions. Oh, okay, this is just partial fractions, and then, yeah, whatever. But that sometimes takes too long. That takes way too long. And this integral comes up a lot when you do u substitutions, so you'll end up having an integral du 1 minus u squared, and then, partial fractions kills you. It's better to just answer it with inverse tang plus c. Okay, so the integral of dx over 1 minus x squared is equal to inverse tang. Okay, hyperbolic trig. Be very careful. Most integrals, when you do u substitutions, like whatever, something, and then you end up something like this. Okay, be very careful. This is negative inverse tang of u. Okay, because it's in a form of this. It is in a form of a geometric series, in a way, kind of, but it's like that. So u squared minus 1, if it's formed like this, then you must use negative. So the integral of 1 over 1 minus x squared, inverse tang. Okay, if it's u squared minus 1, you use negative inverse tang. The next integral to memorize is e to the x sine of x. I'm honestly a bit tired of seeing this because I don't like doing recursive integration by parts. So it's just better to just memorize this. Again, another u substitution skeleton. When you do u subs, let u equal something, and you come across this integral here. So it's better to just memorize this. A very good way to memorize this is the way I do it is I do 2, so I multiply it by 2, divided by 2, and so I just have e to the x sine of x plus sine of x, because I have 2 sine of x, right? I have 2 sine of x. Then I have plus cosine of x minus cosine of x. Okay, what am I doing? Right? What the heck am I doing? What am I doing? What I'm doing is what I have here. This is a product rule. This is a reverse product rule, right? Actually, right? What's the derivative of e to the x? E to the x itself. Okay, so then the derivative of this is this. If you remember the product rule, it goes like this, right? So sine of x, the derivative is cosine of x. Oh, okay. So this is e to the sine of x, e to the x sine of x. Okay. Here, be very careful. It's in a form like this. It's in a form like this. E to the x. So now the derivative of cosine of x is negative sine of x. So we see that it's a minus e to the x cosine of x. And don't forget that we have this half here. So it's a half. And then this is our answer. So to rewrite it again, e to the x sine of x, this is equal to half of e to the x sine x minus cosine x, okay, plus c. If it was e to the x cosine of x, okay, then it is a half of e to the x sine of x plus cosine of x. There you go. Have this memorized, and people will be afraid of you. Okay. All right. Next integral is 2 to the power of x. This is similar to the derivative, except that instead of multiplying ln of 2, you divide ln of 2. So this is kind of short. It's just you just do ln of 2. You divide ln of 2 rather than multiplying it. So the integral. So the integral a to the x is a to the x itself divided by ln of a plus c. Okay, so it's good to have this memorized by heart. Next integral is the integral of square root of x. Okay, we're so used to putting it in the form of, alright, we gotta put this in the form of exponent, right? Sometimes it's just faster to just, okay, this is just 3 halves, 2/3 plus c. And that's okay. I think this one is kind of a freebie. You could either memorize it like me, or turn it into exponent and do it so many times to the point where your brain gets annoyed and it'll naturally memorize it itself. So, but it's good to memorize this integral. The integral of square root of x is just x 3 halves, 2/3 plus c. Just simple power rule. Next integral to memorize is anything in the form of a linear rational function, ax plus b. Okay, memorize this. This is very common, especially when you're doing zero substitution techniques or other algebra techniques. It's very good to have this memorized rather than just straight into u sub let u equal ax plus b, and then all that setup. It's easy to just memorize it. So this is just 1 over a because of that 8x. Okay, that u substitution, ax, you have to divide that. Okay, and then ln of ax plus b. And that's all it is, right? So if I did some u substitution and I end up with like 2u plus 1, this is just a half ln 2u plus 1. I plug in my u and I'm good to go. So this is a good integral to memorize. And finally, the last 10th integral that you must memorize by heart. Oh my goodness. If you do not memorize this integral, you will absolutely die. You will definitely be you will be sad. Okay? And that is secant cube. This, if you remember in your calculus 2 class, this is not a friendly integral. Okay? This is not a friendly integral. It is not at all. Okay? This is disgusting. This is nasty. So, it's best to just memorize this integral because this actually does show up a lot. When you do trig substitution in integration B, they're going to put you in a spot where you end up in, oh crap, secant cube theta d theta. Right? Now what? What are you going to do? Integration by parts? Good luck doing that in 10 seconds. Right? So, it's best to just memorize this. This is equal. Okay, so everything is by a half. Right? So, it's everything by a half because of integration by parts. It's one of those recursive integrals where it's like e to the x sine of x it's one of those integration by part cases where like it reoccurs. So the answer, so we have the half, and then it's the derivative of this of secant. So it's the derivative plus the integral of secant. And if you don't remember the integral of secant x, that's not good. You should have that memorized. That's a very standard integral to memorize. And that is ln of secant x plus tangent x. Okay? So this is the integral of secant cubed. Okay? That's secant x tangent x plus ln of secant x plus tangent x all over 2. Okay? Do not forget about this half. Do not forget about that half. That will kill you if you forget it. So this is the integral. Have this memorized, and you will thank me later. Okay? Especially if you compete at integration bees, you will thank me later. It is crucial to have this memorized. And definitely everyone will be extremely scared of you. They would call you an integration machine. It's, you know, this is brutal. This is a brutal integral. You do not want to integrate this by hand ever. So memorize this, and you're good to go. All right. I hope this is very helpful. Those are all the 10 integrals you must memorize by heart. Thank you so much for watching, and I'll see you guys in the next video. See ya.